Okay, hello everyone. So let's move on. Let's talk about writing discussions. Okay. So, um, so far this is kind of our last section in terms of writing papers. So obviously we've done abstracts, methods, introduction. Abstract, introduction, methods, results, discussion will be this week. So, okay. So the discussion section is going to be where you kind of talk about the actual implications of your results. So like I said before, each section kind of serves and is organized to a very specific purpose. Abstract is your brief summary to kind of help people decide whether they want to read your paper or not. Methods is going to be, introduction is going to be where you introduce your topic, why it's important, what you're asking, stuff like that. Methods is, of course, where you go into detail about how exactly you investigated your question, your results, where you state statistically what exactly did you find. And then the discussion is going to be where you talk about implications of what you actually found. So it's a bit different from the introduction. Well, it's actually very different from the introduction because in the introduction, you're just, again, kind of setting up your question more so, establishing what you don't know about the discussion, but you're not going to talk about what you actually found in the introduction. That's once you get to the discussion, now you've established what you actually found, and you're going to talk about what are the implications of that, right? So discussion section should contain these elements. First of all, what did you find? But this is going to be a little different. So kind of at the top of your discussion at the very start, you want to recap what your findings were and were they consistent with what you predicted, what you hypothesized, right? But importantly here, this is not going to be what you found statistically. So you're not going to say, okay, this condition had this mean, this condition had that mean, the t-test was this, p-values that. You're not going to say any of that in the discussion because that was just all in the prior section. You're just going to recap in English in standard words what you found. Okay? And of course, were they consistent with your hypothesis and your prediction? Another thing here is going to be how do they relate to other literature, right? So, and that might depend a little bit. So one thing to keep in mind is that, I mean, typically you kind of relate your work to other research in the field, but importantly, you don't want to kind of force this or go out of your way to do so, right? So if you're, say, looking at something that's totally novel or, isn't kind of a question raised by other literature, then you don't really necessarily need to do this, okay? So it kind of depends on your research question. For this study, for the planning fallacy stuff, in a way, it definitely does build off stuff. So if we find the planning fallacy, then you can kind of just connect it back by saying that as predicted by other literature, as found in other literature, when people take longer than they think, we found that to be the case with reviewing papers. On the other hand, if you didn't find what was kind of consistent with other literature, then that's something to bring up. But we'll come back to this again, but it's important not to challenge other research unless you have reason to do so. So just for example, with the planning fallacy, I haven't looked at the data yet. I'm going to do that next. But if we don't find a planning fallacy, well, why might that be? It's certainly not because the planning fallacy doesn't exist and isn't a thing. Many studies have shown that. Maybe it just doesn't apply to reviewing papers. Maybe there's some issue with our experiment, right? So keep that in mind. So bottom line, we don't want to go say, oh no, this suggests the planning fallacy doesn't exist, when many studies have shown it. More than likely it was an issue with our particular design. Okay, so these kind of all fit together to some degree, but what do these results imply? So do these results, whatever we find, they suggest that planning fallacy doesn't happen with reviewing papers? Does it suggest that it does happen with reviewing papers? Whatever your implication might be for kind of theory or practice. Another important thing to talk about in the introduction, or sorry, in the discussion, is both alternate explanations and limitations. So there is a bit of a difference there, what we'll get into. When we say alternative explanations, what we mean is just that was there some sort of possible confound? Was there some sort of issue that, you know, might have nullified or invalidated your results somehow? So one thing that was likely an issue, what may have been an issue, again, I haven't looked at the data yet, with our planning experiment is that people don't really have an incentive to do a good job. So because you know it's just for completion, probably a lot of people skimmed it over, didn't really put a ton of effort into it. But when it comes to reviewing actual manuscripts, you do want to, people are incentivized to do a really good job. So maybe if we don't find a planning fallacy here, that could be why. And then are these reasons unlikely? So again, this is where having a rubric for the discussion assignment, I feel a little iffy on. I will anyways, but because it kind of depends a lot on your study, which of these you'll bring up. Generally, you bring them all up, but I mean, it depends a little bit. I don't want you to kind of force it too much and go out of your way to say, you know, something that, like bring up an alternate explanation that makes no sense, just to have it in there. Then kind of are there issues and limitations that are also present? So when we talk about limitations and issues more, we're not talking about, you know, possible confounds or possible reasons why we didn't have an effect, but we're talking about just kind of limits on how maybe applicable this might be. So for example, with, say you ran a study on testing and you only looked at really simple word learning, right? Well, maybe that's not really representative of what people typically need to study. You know, maybe you're typically more interested in them reading a whole passage and being tested on that. That would be a limitation. It doesn't so much invalidate your findings, it's just that, or possibly invalidate them. It's more just that ideally that's kind of something, you know, future research would do to kind of expand on how applicable or how useful these findings might be, right? So I'll give you more examples in a bit, but that kind of leads nicely into the next point, which is what might future researchers want to investigate. So again, let's say you were looking at testing, or let's use a different example. Say you were looking at the remote associates task and incubation. Well, we kind of talked about how maybe the remote associates task is not perfectly valid in terms of an actual problem solving task. It has its uses because it's quick and convenient, but maybe it's not greatly applicable or greatly resembling kind of problem solving we see in the real world. But it's fine as just kind of a tool to initially investigate incubation, right? So if that were the case, a future correction might be people could take incubation and apply it to more realistic real world problem solving, right? That's kind of where the issues and limitations part goes kind of hand in hand with future research. And again, with future research, it can also relate and kind of tie it with alternative explanations. So, you know, again, with our planning fallacy, if we didn't find an effect, maybe because we suspect there wasn't an incentive to try hard enough, well, you know, that might be another future research, and that can kind of go along in this section as well. So there's some flexibility here. You should generally be covering these points. And then kind of a last statement on why this is important, why it's useful, and then that's it. Okay, so consistent with this is kind of an example of what kind of recapping findings. So consistent with our hypothesis, and also is it consistent with what we predicted? So I'm going to kind of use different experiments we've talked about as examples. So this one is just referring to, if you remember back to the attention chapter, some of the eye tracking we talked about, where you have, say, a Kit Kat bar mixed among a bunch of balls. They're the same color, same shape, but semantically, in terms of its meaning, it sticks out, right? Or a panda bear amongst a bunch of rock stars. So that's just kind of, that's one example I'm using. So consistent with our hypothesis, we found that semantically conspicuous objects were fixated on more than non-conspicuous objects. For example, a pack of cough candy was more likely to be fixated on than the rest of the scene when placed amongst Kit Kats. So again, this is what I'm talking about. What do we find? Was it consistent with what we predicted? So yes, it is consistent with our hypothesis. And then just in English, what did we find? Not going into the exact numbers or anything, not mentioning the exact stats, because we just did that in the prior section. Kind of moving on from there, an important thing I want to emphasize in terms of implications is that, or before we get into implications, is that you're not just recapping the results. You're recapping the results in English prior to the implications, right? In this section, what did you find? But when you move on from that to the next part about what this actually tells us, what does this actually tell us about cognition, right? So you're not just going to be in the next section saying this suggests, let me give you an example from the DRM. You can go review that if you need to. These results suggest that semantically related letters are more likely to be falsely recognized than loosely or non-related words. That's not really an implication. That's recapping the results. So we want, well, this is not perfect, but we want to recap our results, but then we want to go on to what does this actually tell us, bigger picture about memory or attention or whatever it is we're studying. So this right here, this is not an implication. This is just saying what happened in our experiment. This is an implication. What these results tell us is that humans rely on the overall meaning of an event, which in turn can lead to false memories. So that's kind of what the experiment tells us, not just what we found. Couple more examples. Our results suggest a practical solution. This is from Incubation. Practical solution to issues with problem solving. Simply take a break may help. Though this may seem like common knowledge, our experiment is the first to demonstrate it empirically. Another example with the attention stuff. This suggests that perceptual features are not the only determinant of attention. Knowledge of the current context and what belongs or does not belong can also influence our attention. So again, what are these things? What do these results tell us? And how can we kind of use them? Okay, so along with these sections is also kind of connecting it to other literature. So are your results consistent with prior work? Do they suggest that prior work is wrong, should be interpreted differently, does not apply to certain areas? So for example, dealing with testing. Although previous work has found that testing improves memory for simple study materials, it does not seem to improve memory for complex materials. So say I was running a study on testing and I wanted to know, does it work with complex materials, not just remembering simple word pairs or whatever it might be. Well, this would be connecting it to that. So previous work had established that it works with, this isn't true by the way, it's just an example. It works for simple study materials like individual words, but we found maybe that it doesn't work with more complex materials. Or in the opposite, prior work had found this, works with simple materials, it also works with more complex materials. So that's kind of how you connect it to other literature. We'll look at some more examples too later. But again, I just want to emphasize that you want to be really cautious here, because a lot of you are going to, find null results due to sample sizes, due to kind of not being able to pilot your studies or making new materials, lots of reasons. You just want to be very cautious about saying, I'd probably almost never say that a result suggests a prior finding was wrong, right? So, for example, let's say the DRM, you ran some kind of study on DRM, like false memories. More than likely, this was an issue with, say, and it didn't work. Maybe participants were too suspicious, having done it before. Maybe there was something wrong with your materials that you used. Lots of different things, right? Not the case that the original was false, because dozens and dozens of studies have repeatedly shown the DRM to work, right? So just bear that in mind. Same thing with planning fallacy, right? Again, if it didn't work, it's not to say that planning fallacy doesn't exist. The most you could say maybe is that it doesn't work with reviewing articles. But again, that could be a lot of reasons. There could be a lot of reasons for that. Could be that people didn't try very hard, didn't feel the need to try very hard, whatever it might be. And just in general, we want to be very cautious with our language, so we don't say prove, we say suggest, argue, supports, stuff like that, right? Everything is based on probability and assumptions, so we don't want to say we prove anything. Okay. So next part is going to be alternative explanations. So this is the question of was there some sort of confound or some sort of issue that might have altered your results? And this could kind of go in either direction, right? Whether you found the predicted result or not, or you found nothing. Either way, you should kind of bring up alternative explanations. So let's say in the eye tracking experiment, well, maybe you could argue that we're trying to get this idea that things stand out due to their meaning, not just due to their color and shape, right? So Kit Kat is the same color, it's almost the same color, same shape, stuff like that, but it stands out due to its meaning. Well, could you argue that maybe it also stands out to some degree due to its perceptual characteristics? So I think the Kit Kat had like a little bit of gold lining on it, whereas the holes didn't. So you could argue maybe that's driving the effect, not purely semantics. Well, something to talk about in the discussion of why that's not likely. And you kind of need to address that. This explanation is unlikely for several reasons. Images were chosen specifically to be as close in perceptual features as possible to other objects in the scene. Another argument you could make, again, obviously not in your paper, but just as an example, our results were substantially larger than those observed in previous literature. So just making the point that when you do focus on only perceptual characteristics, the effects are pretty small compared to semantics, where we saw this big effect. So, and again, with our planning fallacy experiment, there's a lot of limitations you could bring up. So, or sorry, alternative explanations. I mean, whether we found it or didn't find it. Again, I keep mentioning kind of incentive to do a good job. That was probably the biggest one. Maybe it works more with long-term tasks. That's a possibility. Like the original planning fallacy, they looked at writing your senior thesis, whereas this was something you were meant to do in an hour or less. Lots of stuff, lots of reasons, right? So you can kind of think about those and maybe why you did or didn't find an effect. I'm just assuming you didn't find it because it hasn't worked in prior semesters. But I don't know yet. Okay, so then moving on, there's kind of the issue of limitations. Again, these are not, there's a little different from alternative explanations, so not things that could have really changed our results, but just kind of bigger picture, how can we make this better, right? For example, with our, again, it's like I said before, with our remote associates task, with problem solving, ideally we'd want it with something pretty complex, not something like the remote associates task, which like we talked about is not perfectly representative of real problem solving. So kind of a limitation, and then also a future direction you could have talked about with that was applying incubation to more complex realistic problems, right? That would be a limitation that the rat task is not super realistic. Again, lots of things like that. So say with testing, maybe we'd want to know, maybe a limitation, just an experiment we did was that it doesn't really apply to, we don't know if it applies to complex materials based on our experiment, right? So we use simple words. Would it work with something like studying a passage? That would be a limitation. We don't know, right? And again, that's something for future research. Oh, just another thing I wanted to mention when it comes to alternative explanations. So problems with the experiment, obviously, usually the biggest factor. One thing people will often say is that it's an issue of sample size, and this can be true, but not necessarily. So if you remember back to kind of our stats review, remember that p-value or statistical power is determined by effect size and sample size. So we're obviously dealing with small sample sizes here, but keep in mind that if an effect is, so if an effect is kind of in the direction of what you predicted, let's say we get people underestimate how long it would take to review that article, but it's not statistically significant, say it's a p-value of 0.15, and the means are in the predicted direction. Well, that would suggest that it was an issue with sample size, right? Because the means are in the predicted direction, it's getting close to being significant, but it's not, and we have a small sample size. That would suggest that it is an issue with sample size, or at least it could be, right? On the other hand, let's say the means were not at all in the right direction. Let's say they were exactly the same. Well, that would suggest it was a problem with the experiments. With our planning fallacy, if the data comes out and the means are basically identical, or maybe they're in the wrong direction from what we predicted, and the p-value is not even close, well, then that would suggest it's probably not an issue of sample size, right? It's probably an issue of something with the actual experiment. So keep that in mind. So when it comes to your experiments, just make sure this experiment and your experiments, don't just kind of throw in sample size as an issue without really thinking about it. And just some other examples of alternative explanations. Maybe the task was too hard, maybe it was too easy. Say with the remote associates task, say you didn't get an effect, maybe incubation was too short. Maybe the trials were not in the good range, and maybe some were too hard, some were too short. Maybe they were too long, lots of reasons, right? And these are just examples of things that can go wrong in an experiment. Like you could just think critically, so what might have been an issue with this incubation if it didn't work. Okay. So more on limitations. Again, these tend to focus on, are the results generalizable, are they applicable, and are they real? Is the experiment realistic? Those are kind of usually the big things when it comes to limitations. So are the effects too small? I mean, that can depend. I won't really go into that, but another big one is, so the results being generalizable, that's something we talked about. For example, with remote associates task, is the task you use, how realistic is it? Is the material you use, how realistic is that? Stuff like that is a limitation, or can be a limitation. Another one that's people often bring up, which can be true, is the sample representative. So this one's a little tricky. Some people get it wrong because sample size and sample representativeness is not necessarily the same thing. Right? So let me give you an example. Let's say you run 1,000 people, or you run 100 people, but they're all undergraduates from the same year, same age, same demographic. That's not really representative, right? When we say representative, we mean, does it kind of does it represent the population as a whole, not just how big is the sample. So again, you could have 100 people or 1,000 people or 10,000 people, but if they're all pretty similar in terms of demographics, that doesn't make the sample representative, right? So keep that in mind. On the other hand, you can have a pretty small sample size. You can have 30 people, but maybe they're all different ages, different ethnicities, different educational backgrounds. That means that's when a sample is representative, but not actually that big. So just keep that in mind, that sample size and sample representativeness are often not the same. And also just keep in mind that if you do find a significant effect, you shouldn't really be saying, or it doesn't really make any sense to say our sample was too small, right? Because sample size just affects statistical power, right? So if you found an effect, you don't need a bigger sample size. You might need a more representative, a more diverse sample, but you don't need just a bigger sample, okay? So we ruled out different theories. That kind of, that again is where these different sections overlap to some degree. That's kind of ties in with alternative explanations. But say, for example, you kind of had three main explanations, three theories, and you compared two of them, but not the third one. That might be a limitation and then kind of a future direction. So again, like you see, this is kind of where these sections overlap, because this kind of goes right into future directions. So again, with the remote associates task, if you argue that it's not the most realistic problem solving task, well, that's certain future research could certainly do it and apply incubation to a more realistic problem. If you're concerned slightly that with testing you only looked at singular words, right? Well, future research could address that by looking at more complex materials, stuff like that, right? Or with our DRM. One complaint about it is that it doesn't demonstrate how rich false memories develop. So for example, kind of the falsely recognizing or falsely recalling a word presented in the list, like sleep, doesn't really explain how people can have false memories, something like alien abduction, right? But again, so that would be a limitation. That's again future, where you kind of transition into future research. Future research could examine if gist-based memory doesn't in some way play a role in more elaborate false memories. But then also kind of just acknowledging here that it does have its uses, even if that's not the truth. So like testing, like I talked about, we did establish this would be a limitation, then kind of a future direction. We did establish that testing can improve memory for simple word pairs. There's more research to be done. Specifically, future research could investigate if testing is a useful study method for more typical scroll materials such as textbooks or more complex knowledge and concepts. So like I said, future directions can kind of go along with all these other issues. If you have alternative explanations, you can talk about future directions there as well. It's a little bit flexible. But generally, what might future researchers want to know? So keep in mind, though, one mistake I often see with future directions is kind of just a laundry list of future things that could be done building on this topic, and that's not what we want. It's only going to be future directions as it closely extends and builds off of your work, right? So this would be bad. Our results suggest that gist-based encoding can lead to false memories. Future research can consider what characteristics make people more vulnerable to false memories. For example, would older adults be more vulnerable to false memories? That's not really related. I mean, it's not the absolute worst, but again, what do we kind of specifically want to know building on your study? So again, with planning fallacy, maybe if we don't find an effect, future research, and we think it's due to no incentive to try hard, that could be something for future research to address. So it's not just going to be kind of any idea that pops into your head as a future direction, but again, closely related to what you're looking at. So like I talked about here, gist-based false memory, kind of a close implication or follow-up to that would be, does it play a role in more rich false memories like alien abduction? And of course, don't talk about methodology of future research. So You're not going to say something like, this could be examined by blah, blah, blah. No, that's not what you do. And like I said, future directions can kind of go along with other sections. So let's say I was arguing as to why this was an issue of semantic uniqueness as opposed to perceptual uniqueness. What I acknowledge here is that even if bottom-up features play a role, it's likely a minor role, but future research could kind of tease these apart and look at their respective importances. So this is just an example of where future directions can kind of coincide with other parts, like alternative explanations. Just an important thing here. Again, you still talk about the implication, definitely still talk about the implications, even if you didn't find what you expected. So, and even if the research was flawed in some way, that's fine. You still definitely talk about what the implications would be if these were to be addressed. You should definitely still do that. So just kind of a last thing here. At the end, remind people why your results are relevant. Our results help demonstrate this example from DRM, ease at which false memories can develop and how confident people can become in their false memories in such a short time span. Again, still talk about the implications if the issues were to be fixed. So let's say with our planning fallacy again, you definitely should talk about there probably is a planning fallacy, but we didn't find it because X, Y, Z. However, future research can address these issues and then kind of remind people again why this is important. So if those issues are to be fixed and we were to find out that there was or wasn't a planning fallacy, why is that? When it comes to reviewing articles, why is that important? Okay, so just a few common mistakes here. Remember to be formal. Not saying stuff like I believe or I think or in my opinion. That's not good. You don't need to remind people the methods. Again, no statistical results, just in English. What did you find? And then, I mean, this kind of seems like a no-brainer, but you know, kind of think carefully about the implications and how they match up with what we investigated. So we want to be very specific with our implications. So, and that especially helps with kind of establishing the novelty of it. So just an example, you know, people, sometimes their experiment involves something about memory and it's maybe judging your own memory or something. And they'll go, well, this has implications for study habits. And I read it and I go, well, wait, why? Like, I mean, yes, everything, I guess you could say that in a sense, everything to do with memory and studying in some way could relate to, say, study habits and students and stuff like that. But again, you need to be very specific, right? So what does this tell us? Does it tell us that false memory, you know, what does, say, the DRM very specifically tell us about false memory that other studies have not told us? So, well, it tells us that false memory can exist because of kind of relying on the overall meaning. Also tells us how people can become confident and so easily falsely remember something in a short time span. So again, be really specific about what the implications are. Okay, next I'll go over a couple examples.